Now let's think about the stereochemistry of cyclic alkanes. So far we've discussed acyclic alkanes, and excluding the influence of torsional strain, they're pretty much free to rotate as they wish. Things change dramatically when we think about rings, especially 3-membered to 6-membered rings. Here, the ability for bonds to rotate is extremely limited in some cases. This can create the possibility of cis-trans isomerism in the cycloalkane. What do I mean by that? Well, we can view the cycloalkane as having two sides to it, a top face and a bottom face. And when we attach a substituent to the ring, that can result in it lying in the top face or the bottom face. Now, when we attach two substituents, we have a choice. Maybe both substituents are on the same side, either both in the top face or both lying in the bottom face. When this happens, we describe it as a cis relationship. Here's a great example of such a relationship. We call it cis 1,2-dimethyl cyclopropane. Notice the two methyl groups are lying both in the top face here. But there's another possibility, and that is where one substituent is in one side, the other substituent is in the other side. So one top face, one in the bottom face. When this happens, we describe it as a trans relationship. Here's an example of such a relationship. We call it trans 1,2-dimethyl cyclopropane. And you can see that here the left methyl is in the top face and the right methyl is in the bottom face.